My name is Brad Gilbert, and I'm Director of Product Management at FreeWave Technologies. We're in Boulder, Colorado. We've been in the MTEM, SCADA business, building communications devices for 21 years now. So we're not new to the MTEM space. We're not new to the Internet of Things space. So I'll jump in and give a few perspectives on the Internet of Things. We're looking at 25 to 50 billion devices coming online in the next 6 years. And that's going to jump to about 1 trillion devices within the next 10 years. So there's a lot of devices coming online, and what that means is if it isn't online now, it's probably going to be online in the next 10 years. So we're looking at a broad range of devices. What's enabling that? The lowering cost of sensors, communications, processing, and storage are really the fundamental drivers. They're justifying the business cases. The availability of processing and the raw data that goes along with that and creates value through information is also justifying the business case. So this is justifying a lot of things that weren't previously feasible or economically viable. The next item I have here is that your refrigerator is calling. And what this really means is that there's an ecosystem of device. Did my speaker go off? Am I back on? There's an ecosystem of devices and services out there that can easily and quickly be utilized to realize a service or bring a device online. And that's part of where FreeWave is working. And the Internet of Things is really changing what's happening. We started out with smart grid. We moved to smart meters, we moved to smart grid, we now have smart cities, we have smart agriculture, we have smart medicine. The possibilities are endless as we're moving forward. But depending on where you're at in the business, it really is a perspective of how you can play, and that's what I'm here to talk about with respect to FreeWave. So I see for FreeWave, from FreeWave's perspective, we see really two actions that are occurring in the Internet of Things. The creation of data. It's created, it's transported, it's stored, processed, analytics are performed on it. It's transported again to some place that it's either consumed or it becomes an actionable item. The second path is information is requested, it's transported, again it's processed, transported again, and the result is an actionable item or a consumption of that information. So FreeWave is in the transport. You might have guessed that from the previous slide because transport's mentioned in that one more than anything else. So over the last 6 years, we've been looking at what does the Internet of Things do? What do our customers need? And it really falls into 5 categories. The scalability and secure communications is essential to any trustworthy or reliable network. Modularity and flexibility in the communication solution. You have to be able to transport more than one type of information. That transport should be agnostic. We need to increase the bandwidth or connectivity to those end devices of the remote devices because there's so much information out there, data being out there that's being transported. We have to enable new services without substantial investment in development or time. And again, reduce the overall time, complexity, and cost of ownership of communication networks. Those are really the five general areas that we're looking at with respect to the WavePoint product, which I'm talking about. And WavePoint is a platform. It's a communication platform. And why I say that is because it's adaptable, it's flexible, and it's scalable. We can put up to 4 radio modules. I'll touch on that in a bit. But it has a wealth of interfaces that make it easily interfaceable to devices. It has a number of configurations or models that allow it to be incorporated into either communication shelters, enterprise networks, embedded into other devices, such as in the compact embedded module, installed up on a tower some 120 feet up in the air away from the ground in an IP67 enclosure, so it's weatherproof. So a number of communication options, a number of product and housing options, a number of communication options in it. So I'll touch a little bit on the communications and interfaces here and what some of them mean to me. We have 4 Ethernet ports on this device, so it's these are Gig E, so you can connect a lot of devices to it, use it as a 4-port switch, so you don't have to have additional hardware. You have serial, either RS-232 or 485 communications. That's one of the elements we brought forth because of the markets we work in, namely the oil and gas, where there's a lot of RTUs and PLCs out there that still have serial communications. For antenna ports, we do have options for additional antenna ports if you need them. I mentioned earlier that you can have up to 4 radio modules in this unit. And what that really means is you can have segregation of your data transport, local communications. You can bring in Wi-Fi or cellular to meet your customers or your endpoint needs or your communications needs. We incorporated layer 3 and layer 2 services into this so it can be used as a trusted edge device, so you can now bridge out from your enterprise network into the field and run separate subnets. It has an internal firewall. It does a number of additional security aspects that we can talk about offline. And I think that's all for that one. So I'm going to jump into the first case study that I have. And this one deals with the oil and gas industry. The oil and gas industry is, in my brief experience with them, notorious for putting things out where there's nothing else. Out in West Texas, out in the middle of the Saudi Peninsula, places that you generally don't want to go. And what we're seeing in the oil and gas business, and specifically for this customer I'm referring to, is the need for increasing SCADA data coming back so they can improve their operation. They want to go from 4 measurements per day or 4 site reads per day to 6 an hour. So they're going from infrequent to almost real-time data. Not only are they increasing the data rate or the data retrieval, but they're increasing the number of data points so they know more about those production sites that they're working with. They want something simple to install and provision. They want to be able to add new services to this, such as video, such as Wi-Fi. Because of these sites are remote, cellular is not always ubiquitous. So when their people come on site, they now have connectivity not only to the devices on site, but to the back office. So they can solve that problem from the first time they're out in the field. And they want a scalable solution. While I'm going to show 3 data points here, or 3 network nodes. This system will eventually scale out to several hundred well sites, and each of those well sites may have between 20 and 30 sensor nodes on it. So we put out Waypoint at these 3 locations. Again, because we can put 4 radios in this unit, we can now do back-to-back repeater operations. So from the office out to the most distant node, you're going to have that maximum throughput. You're not taking store and forward transport hits. So we're getting 40 megabits per second TCP. I mentioned TCP because that's useful data for your applications. I'm not talking about over-the-air. Useful data. We put a 2.4 gig module in there and brought Wi-Fi to that site. Now, again, their field personnel can come on to the site, connect up with their laptops, their cell phones, their smart tablets. We now have 900, so we can aggregate the data from the other sensor nodes out there to this one, to these Waypoint units, and backhaul that to the back office for SCADA processing. We connected an IP camera, so they now have achieved their need for video monitoring, and we have a terminal server connected up, or a RTU connected up to the device, PLC. So in the ROI on this one is really about reducing the number of devices on site. We took the wavepoint unit, one wavepoint unit at a repeater site, consolidates 2 radios for back-to-back communications, a wave radio unit for Wi-Fi communication, a wave radio for local communications. Also, remove the need for an 8-port Ethernet switch and a terminal server in one. So if we look at the ROI, the cost of all 8 of these devices, 6 of the devices, is 3x what the cost of a wavepoint unit is in an equally configured model. The second case study I'm going to talk about is in smart agriculture. And the challenge in smart agriculture is they can't build the machines bigger. So they have to look at autonomy or semi-autonomous operation. And what does that mean for FreeWave? That means we need to supply vehicle-to-vehicle communications so that they can quickly move information between these devices, and that information is going to be used for synchronizing, positioning, coordinating machine activities. It's also going to be used for video monitoring so that the operator of one machine can see what the operators of the other machines would see if they were present. So that's more along the safety aspect. The other part of this is that they want to move the information from the field to the internet so they can now improve the productivity of the field as well as the management of those fields, also bringing back weather and soil analysis information. And these guys definitely want something that's easy to maintain. So for this one, we're currently still working on this product, or this opportunity, because we launched Wavepoint in March of this year, and we're growing the ecosystem and applications behind it. But in the vehicle-to-vehicle, we achieved 30 megabits per second between the vehicles on the test farm that we're using, and this allows our partner to realize the transfers that they need to do to coordinate activities. It also allows the vehicles to join and exit that network seamlessly. We now have the point-to-multi-point communications going from a grain silo in the area several miles away. So now we can pull that information from those vehicles directly onto the internet, make it accessible to the other applications that would be out there using that. So the ROI on this one is really more functional than cost, because we haven't finalized the cost of it. But the modularity of the unit allows us to reduce integration times and then reduce the development cycle times on services such as the smart agriculture work that we're working on. The ability to have devices seamlessly enter and exit that network simplifies the technical expertise and the operational aspects of those services. High-speed communications, again, gives you real-time communications, so you can synchronize and bring more services to that. And the last one that I really like is the fact that because we have the ability to use repeaters in this application, we now can do some non-line of sight. And this is important because not every farm is flat. So where we're going next is self-discovery of networks, and that really means that because these pieces of equipment are nomadic to some extent, they may migrate from north to south, that the machines from different companies can join the network or work groups and identify themselves and authenticate themselves for that purpose, and also work at improving the performance of the links. Thank you.